All right, so today we're going to be discussing the difference between radians and degrees, what they are, and how to convert between them. So first of all, I'm not going to draw the entire unit circle, or I'm not going to fill in the entire unit circle. I'll draw a whole circle here. But the main point is you know that it goes from 0. I'll write this in terms of degrees first. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then this is the same thing as 360 degrees. And you may be a little bit more comfortable with this, maybe just from hearing it more often or it seeming more familiar, but you can look at it in this way. And so if we're talking in terms of degrees, the unit circle would have like 360 individual little tick marks here for degrees. Now, of course, there's angles that we're more familiar with. So there's 30 degrees, 45 degrees, and 60 degrees. And we work with all of those in between. So we do have these. We can use them. But what becomes more preferable as you move into like trigonometry and you take higher mathematics and so on is it is preferable to use radians. The thing is, degrees are a unit of measurement, much like inches or pounds or kilograms or meters or seconds or what have you. They're a unit of measurement that's just kind of made up. And I suppose you could say that for numbers in general, but more so for degrees. Like we have a little symbol for it, like that's a unit that we're using. Radians are actually just numbers. So we call it radians just to differentiate it from degrees, but when we use radians, we're actually just using the number itself. So if you look at a circle in terms of its circumference, and this is for the unit circle, the reason it's a unit is that the radius is 1. So remember, the circumference of a circle is equal to 2 pi times the radius. Well, if my radius is 1, then I just get 2 pi for the total circumference of my circle. And so what I can do is I can view this right here as either being 0 length or 2 pi length. So now we're focused less on degrees of rotation and we're more focused on how long is this line so far. Do we have no length or do we have 2 pi length? And then what we start doing is we start cutting up the circle into these different lengths. And so 30 degrees is the same thing as pi over 6. So that's a 12th of the whole circle. If you did 2 pi over 12, you get pi over 6. So this right here, if you measured this length, that would be 1/12 of the total length of the circle. If you go to 45 degrees, that's pi over 4. If you go to 60 degrees, that's pi over 3. If you go to 90 degrees, that's pi over 2. You carry on, 180 is going to be pi. And then you come around to 2 pi. And notice this makes sense. This is 2 pi if you go all the way around. Well, what would half of that be? Well, half of 2 pi would just be pi. And so that would be this whole length right here. So when you speak in terms of radians, you're actually talking about the length of the circle so far. Like how long, if I like laid a string out along this, how long would that string be? And it would be that number. Now, of course, it's very useful to be able to convert between. So what you do is that if you have some angle in degrees, so I'm just giving you these to memorize, and if you had the rest of the unit circle, you would usually just sort of use those or derive them. But what if you have some really weird degree like 42.7 degrees? What do you do with that if you want to know what it is in radians? Well, you can use, really you could use any of the facts here of how many degrees are equal to a radians. We're just going to use this one because it's pretty simple. What you do is you would say, well, 180 degrees is equal to 1 pi, right? So in terms of them being the same thing, this is like multiplying by 1. And if I do that, notice the degrees here go away. And so if I multiply this out, I'm going to get what it is in terms of radians. So I'm going to go ahead and do that right quick, grabbing my calculator. So I'm going to do 42.7 divided by 180. And so I get 0.237 and then 2's forever times pi. So that's some little fraction of pi. Notice here we said that this angle here, 42.7, that's between pi over 4 and pi over 6. So if I check that right quick, a fourth is 0.25, and a sixth is 0.167, if I round it. Notice that is indeed right in between those two numbers. 0.23 is smaller than 0.25, but bigger than 0.167. So that is indeed in between these two angles right here in terms of pi. So just to recap, degrees is more focused on the actual angle. You're thinking of it in terms of pointing in a direction. So I'm looking at 30 degrees, or I'm looking at 45 degrees. When you use radians, you're actually talking about the length of that circle thus far, if the whole length is 2 pi, which it is, because it's a unit circle and the radius is 1. So the main thing to recognize is that both are used. If you do more pure math, you're probably going to be using radians. If you do more physics and applied sort of stuff, you're going to be using degrees. And the way you convert from degrees to radians is you just multiply by your ratio. So pi is equal to 180 degrees. So if I want to get rid of degrees, I would just multiply by pi over 180. If I wanted to go the other way, say I wanted to convert pi over 4 into degrees, well then I would just flip this. I don't want radians, but I do want degrees. So notice the pi's cross out, and 180 divided by 4, that's 45. And so we have 45 degrees. Boop. So that's the main idea. Make sure you get comfortable with converting back and forth, because for trigonometry, they'll both be used. And then just keep in mind, if you're doing more mathy stuff, get used to radians. If you're doing more applied stuff, get used to degrees. And that is the difference between them.